Good morning, everyone. Here we are at the panel session for the morning activities of the Auto Summit. It was very rich of insights and very broad. And we have held all the questions for this panel. So we have John from Hyundai, Prashant from Toyota, Joachim from BMW and so many other things, and Tim from NVIDIA, and Fay that appears in our path and has a lot of background in mobility and apps and Verizon and so forth. And we have a lot to share, and we are ready to take questions that were held from the talk times, but also I wanted to say thank you for what you presented and how interesting this world is as it moves forward and it gains steam, but also is overwhelming because there's so many dimensions that have to come together. And so it's a very collaborative, and I define Joachim the shepherd because he has been moving forward, all of us, starting with me at the time of Cisco, when he came to ask for connected vehicles, that we went to do with Toyota before Prashant, I believe.
Yeah.
Anyway, so we are here and the floor is open. Questions could come in. And you can also give your own inputs and pitch in.
Mm-hmm.
Do I see any questions? I don't. All right, so maybe we'll go around and let everybody say a few things to summarize their insights from the morning, starting with John and the walking machines.
All right. So I presented today, if you haven't seen it, this idea of a car that can transform from a four-wheel drive car to a four-legged walking machine. And one of the things that I think would be, from a computing viewpoint, I think they're considerable, but I think a lot of it, for me, looking at maybe two things. One is, how do you control such a vehicle? And how does the vehicle interact with the operator? And I do want it to be an interaction between operator and vehicle. I think the closest analogy would be how a human rider interacts with a horse, right? A horse has some intelligence, has a lot of degrees of freedom, obviously, but it's the rider that is interacting with that horse to do certain things. And certainly the more trained that rider-horse combination is, the more they can do. And I think if you watch the Olympics, for instance, they have these horse jumping events, which are just incredible. And then if you're a novice like me, I could barely, I just sit there, right? And barely get the horse to move. So I think what will be interesting is the intelligence, the interchange between the two. And I do want there to be some automation in that vehicle, and that automation will need to be in the vehicle. So therefore literally operating on the edge, but also the interaction between intelligence and human operator, I think is still an area that is very nascent, still a lot of research to be done, but I think it can apply to lots of different things. And I think we see hints of it. For me, I see hints of it when I think of like Alexa and these devices, smart speakers are kind of going that way. And certainly cars are becoming more interactive too. But I want to say that there are still considerable challenges or different types of edge computing challenges that are out there. And it's not just about autonomous driving or, navigation and that sort of thing, but it's really how do we interact in a way where human and machine are more symbiotic in a way, right? Rather than, and so lots of challenges ahead. And I think,
yeah. And I like this, John, because it's very interesting because even the car in itself, the car then interacts with the environment, with the edge outside, but the car itself is becoming much more intelligent and rich. And I think moving to autonomy very, very quickly when we have this more complex and rich set of sensors coming together. Maybe now we have legs and the wheels. I think it's good to still think that the human being can make sense of it in the progress and then can be assisted deeply by the intelligence. And
Flavio,
yeah, please.
I had a comment here. So what I tried to talk about this morning was how do you deal with the fact that there are different intelligence levels on the vehicle, from human-driven to fully autonomous, machine-driven, and the interaction requires that a machine understands the human, a human understands the other human, and there can be all kinds of combinations. And
exactly,
edge computing needs then to find a way. How does edge computing help us to interpret this correctly so that there are no collisions, happening in
exactly. And in fact, we come from a world of human to computer interaction, which is evolving. But now we have the machine. We have the machine to machine that comes together with the IoT and so on, and the software behind it has to evolve too, because I think it's, and we saw it in Prashant's presentation, where the maps are not the maps with where you go for coffee or for a movie, but is where the car near you will move next. This kind of predictive location, which is machine to machine information.
So I had just recently a discussion with my wife about privacy windows, and basically not seeing the other person when you want to communicate in a driving situation, right? So in some countries that is not allowed, but that is an example. For a machine it wouldn't matter.
Go ahead. Please.
I was just going to say that there's other external factors that are interesting. We did a survey or looked at city driving, and pedestrians like to catch the eye of the driver before they jaywalk in front of him. Except we don't know how to do that for autonomous vehicles, because if there's no driver, exactly how is the pedestrian going to make sure that the autonomous vehicle sees them before they run in front of them? So there's all sorts of interesting human-machine combination problems like that.
Or maybe there will be a human to phone or to kind of your object, and then that machine will communicate with the other machine that will communicate up to the driver or assist the driver. Sorry, Fay, your time. Fay.
No, okay. So wanted to touch on the application development and the use cases of how to use edge computing within that kind of context, especially as you mentioned, location. Because, for example, one of the things that we see today is that when you talk about route planning, every device sends location up to cloud. There is an algorithm that now when I want to know which direction to go, I connect to cloud and I receive it. But when we have this notion of edge and cluster by proximity, that cars can discover each other, and now pretty much cars can inform each other of their each own location. Now, when one car wants to decide how to go from path one, from where they are to where they need to be, that predictive model can work within the proximity cluster, while the knowledge can go to cloud, the global knowledge can go to cloud. So you have this notion of hybrid edge that is possible today. One of the things that I like to touch on, and I love to hear the panel opinion, because everybody's coming from automotive, I'm coming from application, is that there are so many use cases that we can enable today that can utilize this hybrid edge notion. And as these use cases are getting enabled and people are using it, we're going to get a feedback and we're going to be able to iterate on how to advance them over time versus waiting for the advancement to happen. So I'd like to hear your opinion on those things.
Well, let me chime in. on that, Fay. I mean, that's exactly very similar to what I presented as Flavio is mentioning on higher definition map. Basically, it's a very challenging problem. It will require a lot of interaction of dynamic events around. But not all information needs to come directly from the cloud to the vehicle, to each vehicle separately, kind of a thing. And that's exactly where the edge also can play a role, where the edge is kind of information bifurcation aspect, or so it's also offloading some of the processing needed from the vehicle or the cloud to a central very close to the sensors. And basically, when you're sending too much data back and forth, it's also kind of clogged the network and all those sort of things. But edge plays a very, very dominant role in that sense that it can not just do content filtering, but it can also selectively see which car is lacking that information and selectively only send to that information because it's closer to the vehicle. So edge computing is really, really important that way. And the hybrid model you're mentioning about edge playing that in-between role, it's becoming very relevant and people are realizing that.
Absolutely, and those use cases are possible today because with microservice-driven architecture and RESTful API-first approach, that we can create seamless interaction between new components, API to API, right on the edge, right on the computer, on the car, between the onboard vehicle computer and infotainment to the users. That is possible today, and we can enable those seamlessly and rapidly.
Absolutely. I want to say one more thing, actually, very quickly to the point John and Tim mentioned in regards to human factor and personalization. So when the vehicles are moving, each vehicles or the human being driving that vehicle is unique and separate. The cloud doesn't need to know the uniqueness. The edge actually closer to the vehicle knows that very quickly. So what you are trying to do in regards to like adding the human factor or personalization, actually, edge again can play a very important role, being closer to the vehicle, being closer to that uniqueness aspect for each vehicle and each human being driving those vehicles. That's something also we are looking at. So edge has that critical role. Yeah.
And that's what actually we constantly talk about. That we have to start edge in, because now edge has much more intelligent. Right in the car and people in the car and other car around them before it even goes to cloud. So the autonomy can happen much more rapidly. And then you involve cloud when you need global function, when you need global knowledge.
And so we start having questions from the outside. The first one I'll read is very broad. I think we've been talking about that. Where do we go from here, looking forward to the next decade, with more computing, AI, and processing within the car, or more being moved outside the car? Where is the balance between complexity, cost, and functionality? Big one.
Well, I think that the computing power will increase in both sides, both in the vehicle as well as outside the vehicle. But what is difficult now to determine is, when we talk about edge computing, who actually operates these edge devices. So, for example, in a highway situation, if the highway is managed by either a federal highway or state highway, the Department of Transportation could operate edge computers and share data with the vehicles. And vice versa. But it could also be that or the OEMs have to determine whether they want to operate that edge computers themselves, or whether they are always, or whether they have preferred partners in this, like the telcos. I think that is an unclear topic at the moment. And
I think Joachim, I think this is similar to what's going on in a lot of these industrial IoT deployments. The pieces are coming together, but it's not clear who owns them, who manages them, who is the reference. But
we do see certain trends that, autonomous car by definition needs to be autonomous. So the edge computing has to be standalone. Now, when you are connected, you can use the additional, whether I'm getting object maps from other vehicles, where I'm getting, traffic light, traffic cams, knowing pedestrians about to jaywalk. I can use that as an extra sensor. I call it my look around the corner sensor, right? So beyond the sensor of the car to make a better experience for the autonomous car. But you're using edge computing as an additional sensor. And that's what we're seeing trending today.
Yep.
I like to comment on that question, because it's a question about where do we go from here, and I would suggest let's start. We're gonna go to the moon. We're gonna start creating new use cases that we didn't even thought of it's possible. But the key thing is to start simple. Let's start utilizing the computers that we have control on. The onboard vehicle computer, the infotainment, and the application that running on the user device, and enhance the experience of driver, passenger, and their interaction with the application. Today, we still don't have a simple way of playing music, but from if you have multiple people in the car, that you constantly between the Android Play, Apple Play, or this connection only works with one device, let's disconnect that one and connect the other one. This use case, simply, it's possible today to enable between the user mobile device, infotainment device, and that's it, without being worried about who owns the next edge. Now, if we start focusing on things that we have control over within the car and application that users are using, and then as we evolve and other decision makers put now new edge computing or hyperscale servers on the highway, then it becomes, okay, I now discover a new resource that can process an image that my car, the camera detected, so that if I need more compute, I can offshoot it from edge to that hyperscale server that is available. So if we start from as edge is, from really hyper local experiences that are possible today, and then again iterate and then decide over time how will evolve, it's up to our imagination.
Yeah.
I wanted to give an example.
We have only
Yeah.
Go ahead. We have two more minutes or one more minutes now, and there's a couple of questions that remained unanswered. Go ahead, Joachim.
I wanted to just very quickly give you two examples. So if you have a pothole on a road, or if the lane marking is not correct, then it needs to be determined whether you tell the OEM he needs to deal with the situation, or whether there is an obligation from the road operator to have perfect roads. And so I think this is an unresolved liability issue at the moment. It needs to be addressed.
Yep.
And the last one is probably is about the weight, power, complexity, and the amount of computing that is required by this autonomy, and how it really plays into the form factors and cost for consumer and manufacturing of cars. So it's
that's a multidisciplinary design optimization problem, right? I think you need to have, and there's economics involved there too, and cost models and so on. So that one's a tricky question to answer quickly, other than the fact that you need to have multidisciplines, engineering and economics, business side, finance side, to really come together on that one.
And also balancing between the autonomy and what is in the car and what is supported outside at some point.
And that's why we're seeing a lot of scalable solutions in this space. That's in scale from something that can be windshield mounted, like maybe 20 tops, to something that's going to be in the trunk, on the couple of hundred tops.
Yeah.
Yep.
Yeah, but one thing I'll add is that this problem is there everywhere, and every new technology which comes along, and we have to advance technology without worrying about these factors too much. Because if you look at our phones right now, the phone has capability which we didn't imagine 15 years ago. Exactly. And now so much miniaturization happened, so much technology advancement happened that we now can imagine that. If we had not worked on those things, we have not got to that point.
Yeah,
we
it's
have
funny.
to keep evolving
We
technology.
it's funny we still call them phones because people rarely use them for that.
True, true.
Okay, on this
Many
note,
cars.
I think on this note, we need to wrap up. Thank you. It was fantastic also to meet you, new people here, and the exchange was wonderful. The topics exciting and a lot of work. We'll meet again and again before these problems are solved. Thank you so much, everybody, and we'll see you later in the keynote and in the sessions of the afternoon. Thank you.